Hello, and welcome to my Realize Live virtual session. And thank you for welcoming me into your home from within my home. Today, I'd like to talk to you about NX Design for Additive Manufacturing and how we're helping to drive industrialization through our NX leading industry design innovations. Our agenda today will talk about opportunities to your business, trends in the market, the challenges that many customers face, Siemens' unprecedented solution offerings, as well as the successes that we and our customers are having with our solutions. My name is Todd Perella, and I work in the NX Industry and Design Product Management team here at Siemens Digital Industries Software. Additive manufacturing can help you reimagine your business. Imagine a time in the not-so-distant future when your next design innovation, your next performance improvement, or your next in-service fix is only as far away as the next print job. That's a real possibility. The implications of additive manufacturing on your business could be enormous. Companies are already realizing benefits for additive manufacturing, including reduced design assembly complexity, improved design performance, increased design functionality, and increased manufacturing flexibility. What are some of the industry trends that we see? Well, in January of 2019, Dimensional Research conducted a survey of 3D printing stakeholders in the manufacturing market segment. This survey was sponsored by Jabil. Of the surveyed manufacturers, 61% are currently using 3D printing to produce at least 10% of their functional end user parts, whereas a year ago, that was only 36%, an amazing percentage increase. 79% of surveyed manufacturers expect their use of 3D printing for production parts or goods to at least double in the next 3 to 5 years. And 83% of manufacturers say that 3D printing can save at least 50% of their time compared to conventional methods. What are some of the barriers to greater adoption in the market? Number one is we are hampered by conventional design thinking. With any new manufacturing technology, the design has to also evolve and to consider new ways of designing to get the most value of the manufacturing process. We see companies that are mired by a significantly disconnected process chain, multiple softwares disconnected and not working seamlessly together in an integrated workflow. Because of this, they're hampered with multiple data file conversions, introducing the possibilities of mistakes. And none of this is controlled from a workflow or data management perspective. Here at Siemens, we bring to you the world's most comprehensive digital twin, the digital twin of the product, production, and performance, all working seamlessly together. We can use our technology like MindSphere to collect in-field data analytics and use that as insight for greater performance improvements in your product. We offer the means through integration for continuous product and process improvements. Our business value to all of our customers is our process integration, the connectivity between design, simulation, and manufacturing that is unprecedented in the market and brings great business value to our customers. I'd like to now show you some demonstrations of some of the innovative NX CAD technology and how it sets us apart from the competition and can really help you streamline your design for additive manufacturing workflow. First, I'd like to discuss convergent modeling. Additive manufacturing world was hampered by the use of facet data in their workflows. But that's not always a bad thing. As we know, topology optimization solutions in the finite element modeling space also result in facet data from the design. The problem with facet data historically was that it wasn't easily reused within your CAD applications. Convergent modeling technology from Siemens and NX changes that whole story. With convergent modeling technology, we can work with mesh data seamlessly in an end-to-end integrated design workflow. We work with the data just as if it's any other CAD geometry. We can build up features, parametrics, and history to allow you to easily change and control the geometry. Earlier in this demonstration, you saw using a minimum radius adjustment to help smooth out stress concentrations within the part. In this section of the demonstration, we are reconstructing pieces of this design in a feature-based parametric manner, allowing us to incorporate variation and variability into the design and to parametrically control the design and also more easily incorporate design for manufacturability into the design. Here we see the ability to combine the classical CAD features, parametrics, and history seamlessly together with the topology optimization mesh results without any need to completely reverse engineer or reconstruct the model. Another very important aspect of the value we bring to this market is our comprehensive set of design for additive manufacturing checking and validation tools. Checking things like overhang angles, wall thicknesses, minimum radius size, print orientation, and other are all easily possible in an integrated manner live within your design model. In this example, we are not only using the design for additive manufacturers checkers to understand how we may need to revise the design to make it more suitable for additive manufacturing, but we are also leveraging synchronous modeling technology to easily make changes to this design, even from the fact that this design did not originally come from NX. It came from some prior legacy CAD system. Opportunities for lightweighting are one great benefit of design for additive manufacturing, and the ability to incorporate lattice structures into your design is an important and integral part of that process. With our integrated NX lattice structures design tools, we have an incredibly tight, seamless integration between design and simulation. In this example, we can leverage Fields technology from our SimCenter 3D solution seamlessly in the CAD environment, such that we can vary the rod sizing, the rod diameter sizing variably throughout the design volume. And this variability can be based on the simulation loads coming from, for example, the loads department within your organization. All this information is 100% fully parametric and easily integrated into your design models. Here we see incorporating a variable rod diameter structure where the structure is thicker at the base, where it needs to be thicker and stronger, and it can be sparser and less thick at the tip of the blade, where we can get greater lightweighting for speed and performance. One of the great aspects of our integrated design for additive manufacturing checking and validation tools is our connectivity and collaboration with manufacturing. It's as important or more important than ever for designers to understand how things will be manufactured and make better decisions earlier in the design process based on that information. By having these tools at their disposal and being able, in this case, for example, to run a build orientation optimization at the design phase, designers can understand how a manufacturing person may need to orient this part for greater producibility. They can evaluate that information. They can look at it and make smarter decisions. For example, where manufacturing is saying they want to orient it such that we minimize the support volume required to print it, thus reducing the amount of material we use. The designer can make that check. They can understand what type of design impact that may have in their design, and they can easily use that and share and collaborate with manufacturing. Collaboration is key to success and industrialization of additive manufacturing. Here we have built up a fully featured parametric model with lightweighted structures incorporated. We all know that build orientation is critical, and minimizing support structures is also important. Here, because of the parametric nature of the NX Integrated Lattice Structures tool, it's so easy for me to go back in and make rapid design changes to the structure, reorienting it to the new build orientation such that support structures will not be required in this design. significant value add, significant fewer iterations prior to creating your first successful production part. So what really are the potential benefits that our integrated solution offering provides you? Brian Neff, CEO of Centavia, recently presented at the ARC Industry Forum in Orlando, Florida in 2020 of this year. His presentation was titled The Green Future of Manufacturing, and it was a discussion about how additive manufacturing can have positive environmental impacts and still allow us to produce the products that we use and consume every day. Some of the benefits he demonstrated were staggering. For example, the possibility to go from 12 different CAD systems down to one, which is a significant IT infrastructure cost reduction as well as training reduction. A 95% reduction in importing and exporting of data, which can yield an 80% reduction in potential human error in the workflow by not having to continuously transfer data from one system to the next. Many people have also expressed the importance of being able to bring down the number of trial builds from the high numbers of today with extreme costs and extreme material usage down to a few minimal, utilizing the digital twin to validate the design as much as possible before doing print trials. The ability to go from fewer print trials directly into production is key to helping industrializing the additive manufacturing process. Of course, our tools offer 100% associativity across design, simulation, and manufacturing. That alone can offer significantly faster iterations in the workflow. As we know, up to 85% of all of design is making changes based on your learnings in simulation and manufacturing. Your ability to change things quicker, more easily, and faster can yield significant productivity improvements. Overall, Brian's input demonstrated that they believe they could realize a 50 to 75% reduction from the design to the final part creation. Those types of percentage improvements are staggering. Next, I'd like to show you one of our more recent customer successes of a company in the small and medium manufacturing market segment, GEL.
My name is Gregor Jell. I'm one of 3 managing director of our company, Jell. We are 32 years old. We have 5 services and 2 key points. The key points are development and 3D printing. We are a supplier for household devices, for example, coffee machines and vacuum cleaner. We work for small companies as well as for big companies and brands. In 3D printing, we have 10 years experience, and we start as pioneer and lead the market.
So my name is Sebastian Hochwater and I work at Jell in the product development and design. Our CAD software is Siemens NX and we use it now for many years. So the advantage of a program that has all the features in one package is that you don't need to transfer data between a program. So you don't need to export and import files from one to another program, and that also makes up for a great time saving. So in this part we used a lattice structure with a wall thickness of 1.5 millimeters and could reduce the weight by 50%. And because designing and simulating is both in one system, we could do it in 5 minutes.
My name is Benedikt Reiter and I'm working as a designer and developer for the company Jell. I use NX topology optimization for weight reduction. According to the market, the customer wants to have light parts because it's saving energy, so the NX topology optimization is getting more important. In my opinion, the integration of functional tools in CAD is the biggest strength of NX. One very special thing in NX is that there are quite underestimated features, for example shell. And you can do a lot of really cool things with the shell feature. And there are a lot of features like that. There are features which are supposed to be quite simple, but they are underestimated.
My name is Alexander Baumgartner. I'm a designer. I'm responsible for the print preparation. My task is to find the perfect position of the part and create optimized support structure. With associativity, design changes can be done easy and fast.
We are a small company, you know, and we need a big partner. Siemens help us to use NX and to get the worldwide series for 3D printing. If I see as manager my staff goes better and better with Siemens NX, it means we're on the right way.
Siemens, ingenuity for life.
I always love to see how companies are using our technology in innovative means. I'm also very happy to see not only the enterprise customers that we serve, but the small, medium business manufacturers and how we can bring great value to them as well. The capabilities I've been talking to you about today have been recognized in our industry as well. Recently, we've received 2 awards, the Edison Award in partnership with our partner HP for helping to bring 3D printed high quality parts into a production volume. At the technology level, Develop 3D has recognized convergent modeling technology, a Siemens innovation and invention, as one of the 30 new technologies from around the world that they firmly believe could give your 2020 product development work a major boost. It's great to be recognized in the industry as a leader. What are the solution offerings that we bring to you in the market? We bring a comprehensive suite of tools, but also scalable set of capabilities, from design through simulation, manufacturing, printing preparation, and through into manufacturing operations. At the design level, you can extend an existing mock seat to incorporate design for additive manufacturing capability, including lattice structures and topology optimization. You can then, as you grow with your business, extend that capability into simulation and manufacturing preparation. We support a number of manufacturing methodologies for additive manufacturing and the integration of our SimCenter 3D additive manufacturing build process simulation. All of this capability is managed under the PLM backbone of Teamcenter, which gives greater business value by we're able to work in a managed and controlled environment. Today, after my session, I encourage you to also sit in on Slade Gardner, president of Big Metal Additive presentation on industrial production of big metal additive structures. The technology that Slade is bringing to this industry is unbelievable and unprecedented, and is going to revolutionize the ability to print very large, big metal additive structures for a number of industries. Siemens Digital Industries software is where today meets tomorrow. After this session, we're going to have a live question and answer session where you can speak to me live. I look forward to being able to speak with you and answering as best I can any of the questions you may have. We also would like you to fill out a short post-session survey to help us improve how we communicate with you during this virtual world. With this, I'd like to say thank you very much for listening to my session. Again, my name is Todd Perella, NX Industry and Design Product Management. You have my contact information. I welcome contacts from you guys at all at any time. I'd be happy to answer your questions or put you in contact with people who can. Have a great day.